To find all the possible rational roots for the function h of x, we're going to need to figure out our p's and q's, and then we will have p over q, which will be all of our possible rational roots. P is going to be all the factors of my constant. So this is p, the factors of 45, which are plus or minus 1. 45 is not even, so not 2. I can use a calculator for this if you'd like. Plus or minus 3, because this is divisible by 3. 4 is not. It is divisible by 5. It's not divisible by 6. It is not divisible by 7 or 8. It is divisible by 9. And it is divisible by 15 and 45. So then from there, also you can see that 1 times 45 is 45, 3 times 15, and 5 times 9. So they even each other out. Q is going to be all of the factors of your first coefficient, or the coefficient to the highest degree. So the factors of 5 are plus or minus 1. It's not divisible by 2, 3, 4, so plus or minus 5 is all that's left. So all we're going to do now is we're going to do p over q. So I'll do p over q, and I'll just do everything over 1. Everything over 1 is just itself, so I'm going to rewrite all of this. So I could get plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45. And then everything that goes over 5. So, and I don't need to write anything twice. I don't need to be redundant about it. So if I do 1 over 5, that's plus or minus 1/5. 3 over 5 is plus or minus 3 over 5. 5 over 5 is the same as 1, so I don't need to write that again. 9 over 5. 15 over 5 is 3, which we already have, and 45 over 5 is 9, which we already have. So this is going to be the list of all of our possible rational roots. Now, if we have to write the function and we give you all of the roots, then we can just write our function in factored form and say the function of x is equal to, if I know that my y is 0 when x is 6, 10, negative 5, and 8, then I know that x minus 6 equals 0. So that means x must be 6. And x minus 10, if x minus 10 equals 0, then x must be 10. And x plus 5, so that if I plug in negative 5, I get 0. And x plus 8. And that's all you have to do. If I give you all of the roots, you just need to put them in. That varies a little bit for number 8. For number 8, it's going to change a little bit because we have imaginary numbers. When we have imaginaries as our roots, you have to think that if we had an imaginary number, that means we were dealing with a square root. If we were dealing with a square root, that means that all of our answers are going to be plus or minus. So anytime you have an imaginary, you're going to have x plus 5i and x minus 5i. We're going to have the conjugates. We'll have the same thing for x minus 7i, x plus 7i, and then lastly we'll have x minus 3, because if x minus 3 equals 0, then x is 3.